deals with systems of equations and inequalities. So chapter 5, systems of two different types, equations, inequalities. We only have 3 sections to look at. So let's start with 5.1. So this is called 2 by 2 in short. 2 equations, 2 variables. 2 equations, 2 variables. Okay, let's choose a problem. We are on page 555. Let's start with problem 6. Oops. On page 555, and that is x plus y equals 6 and y equals 2x. So please keep the equations together. In the next section, when we get to chapter 6, we're going to have 3 equations together. So please keep them together either with this symbol, which is a brace, or a bracket, whatever you want, but they have to be together. Okay. So forget about the second equation, and if you ask me to graph this, what will I graph?
I think that would equal 6.
What is this? What is this? Yes, but what is the graph of x plus y equals? A linear equation. Very good. So I will graph a line. Forget about this first one. What will I graph if I graph the second one? Correct. So there are 3 possibilities when we solve systems of 2 equations in 2 variables. First possibility is they meet in one solution, unique solution, one solution. The second possibility is when they are parallel. How many solutions? If 2 lines are parallel, in how many points will they meet? No solutions. Very good. And here's the third possibility. This is one equation. And careful, here's the second one. Infinitely many solutions. What does it say? 2 lines cannot meet in 2 points. So there is no such thing. So they either meet in 1 point or they meet in all of them. There is nothing in between. She's very nice. Yeah. She's my guest. She's my guest. Okay. You're safe next to Priscilla. Very good. Okay, so we cannot encounter any other possibility. One solution, no solutions, or infinite. Okay, so we're going to look, there are many methods of solving systems. Why is this a system? Because 2 conditions have to be fulfilled at the same time, or even 3 conditions or more. But in this case, we are only looking at 2 equations in 2 variables. Bless you. So they are put together. They have to happen at the same time. Good. So we have 2 options here, many different methods, but for the purpose of section 5.1, we are only looking at substitution or elimination. In your book, this is called addition method. Same thing. Call it the way you like. It doesn't matter. Okay, so we have a problem. We have a system that I copied. So this is x plus y equals 6 and y equals 2x. It happens that the second equation is already solved for y. I'm going to take advantage of that and replace in the first equation y by 2x. So can anyone dictate the new equation, the new first equation? Which means 3x equals 6, which means x equals 2. Awesome. Is it done? No. I got x, but I don't have y. That's not a problem. All I have to do is just go back where I had y as 2x, and then I will determine that y equals 4. It appears that the solution is 2, 4. Do I know that for sure? No. I have to go back and check. The solution must work in both equations. Is 2 plus 4 6?
Yes.
Good. Is 2 times 2 4?
Yes.
So then I will say this is definitely a solution and no one can find another. Unless we have all real numbers as solutions. Infinitely many solutions, I should say. But otherwise, if we found one solution, no one can find a second one. Let's look at another one. 18 it is. Perfect pick. This is y equals negative 1/2 x plus 2, and y equals 3/4 x plus 7. Great job. It's another typical, or I should say common situation, or doesn't require a lot of work maybe, only because both equations are solved for y, which means this piece must equal this piece. There's no other way, because they're both equal to y. So then negative 1/2 x plus 2 must be 3/4 x plus 7. No question about it. So how do I solve such an equation? What is it, first of all? Linear equation, very good. I recommend let's get rid of fractions. What should I multiply both sides by to get rid of all fractions here? Of? That is too much. It's not wrong, but it's too much. What is the least common denominator of 2, 1? Exactly, 4 indeed. So negative 1/2 times 4 is negative 2x. 2 times 4 is 8. 3/4 times 4 is 3. And 7 times 4 is 28. Let's take a moment and see if we agree with this. So one more time, negative 1/2 times 4, we get negative 2. 2 times 4, we get 8. 3/4 times 4/1, we get 3. And 7 times 4, 28. Agreed or not?
Agreed.
Perfect. So then we move x and we move 8. So this is negative 7x equals 20. Oh, I'm sorry. How did I get 7? Negative 5x equals positive 20. So then x must be negative 4. That's not good enough. It's good, but it's not good enough. We have to go back. Let's say we go back here. And negative 1/2 times negative 4 is 2 plus 2, 4. It appears, I'm not sure, that the solution is negative 4, 4. What do I need to do? Plug it in, the original problem. So for where I see x, I write negative 4. Where I see y, I will write 4. I already know that this is true. Negative 1/2 times negative 4 is 2, and 2 plus 2 is 4. We checked that. Now let's check the other one. 3/4 times 4/1, but this is negative, will be 3. But negative 3 plus 7 is indeed 4. So I will say yes, indeed. And no one can find another. And this is the method of substitution. Any questions on this method before we move on to the second method, elimination or the adding method? Charisse, are you okay?
Yeah, I got stuck. I don't know why.
But is it clear?
Negative. So we just put 4 in once we found x equals 4, and we just substituted.
X was negative 4 and y was 4, so we substitute everywhere here to see whether the left-hand side equals the right-hand side. And it has to work in both equations.
So
Which one do you want to look at?
So we have to put 4y.
I replace x by -4 here and here. And I replace y by 4 here and here.
At the same time?
Absolutely. So -1/2 times -4 is 2, and 2 plus 2 is 4. Check.
So y equals 4. Okay.
So 3/4 times -4 is -3, plus 7 is 4. Check. Better? Okay, let's look at the other method. Same page, 555. Let's look at 25 it is. Perfect. In 25 we have 4x plus 3y equals 15. And 2x minus 5y equals 1. The method is pretty similar. We are getting to an equation with only one variable in a slightly different way, but it's the same idea. I have to manipulate these two equations somehow to get an equation with only one variable, because I don't know how to solve an equation with two variables. Same thing here. It's just that it's different. We are getting to the same step, but in a different way. So let's analyze the coefficients. So I have 4 and 2. It's very clear that if I multiply the second equation by and add them, x will go away. But what should I multiply by? Yes. So the idea is that I would multiply the second equation by a number so that when I add the equations, this plus this will give us 0. -2 indeed. So we copy, please keep the equations together. We copy 4x plus 3y equals 15, and then -4x plus 10y equals -2. So I cannot pick and choose, we know that. We have, when we decide to multiply an equation by -2, I have to multiply all terms, both sides, by -2. And now I eliminated the variable that I wanted to eliminate, because when I add 4x to -4x, I get 0. When I add 3y to 10y, I get 13y. And when I add 15 to -2, I get 13. Therefore, y happens to be 1. So this is the method of elimination. However, we haven't finished. How come we haven't? Because I did not determine x. So let's go back with y anywhere you want. It doesn't matter. Let's say we go back to the first equation and we have 4x plus 3 equals 12. I'm sorry, I didn't mean to write 12. I meant to write 15 first, and then 12. So then 4x equals 12 and x equals 3. What does the solution appear to be? I don't know if it's true. It appears to be 3, 1 with a question mark. I'm not certain. But I will go back with 3 and 1, 3 and 1, 3 and 1, and check. 4 times 3 plus 3. Check. 2 times 3. 6 minus 5. Check. I will say definitely. For sure. That is the correct solution. Let's look at a word problem now to see when we apply this. What is it used for? Okay, on page 559. Any questions about the method? Do you think we should look at another elimination? Let me know. Okay, on page 559, let's see if we're interested in any of these situations. 82, when an airplane flies with the wind, it travels blah, 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 against the wind, blah, blah, blah. Find the plane's rate in still air and the rate of the wind. Let's look at 78. North campus of a small liberal college, all arts, 10% of the students are women, 40% blah, 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 blah.
What page are you on?
559. Sure.
So like 82.
82. When an airplane flies with the wind and against the wind, it's a very interesting situation because let's say if we want to travel during winter from the East Coast to the West Coast is the same distance that if we fly from the West Coast to the East Coast, assuming we're going from the same town to the same town. However, when we go to the West Coast, it will take us 7 hours. When we come back, it will take us 4. I'm exaggerating a little bit. Why is that? It's all about the wind. It's all about the wind. The western winds will speed us, right? And that's why we cover the same distance in 4 hours. But when we go against the wind, it will slow us down. We're not going to be able to get there in 4 hours because it's a headwind. And this happened to me one winter not too long ago. I left in December. The winds were so strong that we did not make it. We had to make a stop to refuel. We didn't have enough fuel for 10 hours of flight. It was a 10-hour flight. I thought we were above China by the time we got there. It took so long. Of course, I'm kidding. It took so long. I left here at noon, and I got to my destination at 3 a.m. the next day. And it would have been normally a 5.5-hour flight. So it's an interesting situation. Okay, enough of that. 82 on page 559. So when an airplane flies with the wind, it travels 800 miles in 4 hours. So this is 800 miles. Remember, every time we read a problem, we take notes, we draw a picture, anything that helps us become aware and remember the information given and what is asking us to do. So I'm going to say this is the airplane and this is the wind. Plane and wind in the same direction, 4 hours. So the wind and the airplane are helping each other if you want. Of course, the wind is helping the airplane. So they have the same direction. Okay, now let's read on. Against the wind, it takes 5 hours to cover the same distance. So since I cannot change the wind, I'm going to say this is the airplane now. So with the wind, it covers 800 miles in 4 hours. Against the wind, same distance, but it needs 5 hours. Assuming uniform motion. By uniform motion, we mean no acceleration, which we know it's not possible, and no deceleration, which we also know it's not possible. If I want to get from point A to point B, I have to start from 0. I have to accelerate till 45, 50, whatever miles an hour. And then when I want to stop, of course I have to decelerate. I have to reduce the speed, right? So assuming in this case uniform motion, for which distance equals rate times time. However, this is an ideal situation. It's not 100% real life. Yes, I can drive maybe even 100 miles at a constant speed, but if I need to get to that speed or stop, that's no longer a uniform motion. Okay, so we have how many variables? Let's read the problem one more time and decide how many variables are in the problem. When an airplane flies with the wind, it travels 800 miles in 4 hours. That's the first scenario. Against the wind, which is the second scenario, it takes 5 hours to cover the same distance. So I drew a distance of 800, but 5 hours, and opposite directions for the airplane and the wind. Find the plane's rate in still air, what the plane can do, and the rate of the wind. So how many variables we have to find? 2. Very good. Which means you are going to come up with 2 equations. 2 variables, 2 equations. So let's write an equation for the first scenario. And we are using distance equals rate times time. So what is the distance? Let's start from the left. Distance is? Perfect. But now let's think about the speed. So let's give them some names. I'm going to call this one x and this one y. So therefore this is y and this is x. The speed of the airplane, we denoted it by a. By x, it doesn't matter. You can use a, b, c, whatever you want. And the speed of the wind, I said it's y. So when the airplane flies with the wind, they also call it tailwind. What is the actual speed of the plane? Of course. And what is the time? So this piece is this piece is this, and now I need the piece which is time. 4. Perfect. Can anyone give us a scenario, an equation representing the second scenario?
But how did you get the x plus y again? You said that's the distance without the wind. Is that what you said?
No. So imagine that I ride my bike, and let's say all I can do is 10 miles an hour. And I have a tailwind, a backwind of 2. What is my speed now?
Did you say 10?
Exactly.
Oh, okay.
Exactly. What if I go back now? All I can do is 10. Nothing. This is the maximum I can do. But I have a headwind of 2. What is my actual speed?
8. Okay.
Perfect. Okay, so can anyone give us an equation for the second scenario?
800
Perfect. Equals.
x minus y.
Of course. In parentheses, don't forget. Times. That's it. Obviously, I will clean it up. How do I clean it up?
Switch.
That's not how I clean it up. It's not a mistake.
Put the coefficient. Well, not a coefficient. Is that a coefficient?
How do I clean these 2 equations up?
Make it x minus y parentheses. Well, 5 times x minus y.
I will divide both sides by 4, and I will divide both sides by 5. By cleaning it up, we mean simplifying it. Is it a mistake not to simplify? Of course not. Will it make my life easier? Of course it will. You'll see in a moment why. So 800 divided by 4, so I have x plus y equals 200. And then x minus y equals, see how much easier this is? I don't even have to multiply. These 2 go away, y goes away, and then I have 2x equals 360. So I got the speed of the plane. What is the speed of the plane? And the answer is 180, and I need measurement unit. Thank you. With x, I go back anywhere you want, it doesn't matter. If x is 180, how much is y? Very good. Y equals 20 miles per hour. It appears that the solution is 180, 20. Is it true? I have no idea. I haven't checked. Give me a second and I will check. So 180 and 20, 180 and 20. How much is 180 plus 20? 200 times 4. Check. How much is 180 minus 20? 160 times 5. Check. 160. 16 times 5 is 80. Yep. So I will say definitely yes. So this was an application in which we used elimination. We created a system with 2 equations in 2 variables, and we used the method of elimination to find the speed of the plane and the speed of the wind. Is this okay? Any questions? I'm sure you remember some of this from your previous classes. Okay. We repeat everything we just discussed, but for nonlinear systems. 5.4, non-linear systems of equations. This you may have not seen before. Same two methods, substitution, elimination, everything the same, but a little bit more sophisticated systems. On page 587, please choose, if you'd like, from 1 through 18 for substitution, and for 19 through 28,
10.
19 to 20. Very good, 10 it is.
Oh, you know what? I changed my mind.
Okay,
That's 16.
16 it is. X plus y equals -3. Keep the equations together, please. X squared plus 2y squared equals 12y plus 18. Yes, it's more work because it's x squared and y squared and 12y and maybe a term with x. But the idea is the same. Now, first of all, I would like to clean this up a little bit, but I can't really. I cannot use elimination. Their variables are not the same. Here, I was able to use elimination because I had x, and y, and -y. But here, I have x squared. I can't combine with x or anything. So the only option I have here is elimination. Now, what is very important to remember with elimination is you will always use elimination only for that particular variable that has 1 or -1 in front. If you have 3 and 5, can you still eliminate for one of the variables? Yes, but it's going to be more difficult because you're going to have a fraction to deal with, and we don't want that. So let's solve the first equation for either one. Now, one more time before you say anything, give me one more second. Notice that there is only one x, but there is a y squared and there is a y. Which will be the easiest thing to do? To solve the first equation for x and plug it in the second one, or solve the first equation for y and plug in the second one in 2 spots. Right. Excellent. So I will solve for x, and I write -y minus 3. Because there is only one spot in which I need to replace x by -y minus 3. If I go the other way around, then I would have to replace it here and here. Is it wrong? No. It's just it's more work if we do that. Before we substitute, I want to discuss one thing with you. Y plus 3, if I need to square it, is identical with -y minus 3 only if I need to square it. Here's why. All terms will be positive. Here, I have negative and y plus 3 in parentheses. Do you agree? I am allowed to factor out -1. And when I square this, -1 squared will be 1. So if both terms are positive or both terms are negative, it's not going to make any difference. Only if we square them. If we don't square them, of course they're not the same. But if we square them, they are the same. So I'm explaining this because it's easier than squaring -y minus 3. And it's very easy to make a mistake. So when I replace -y minus 3 squared plus 2y squared minus 12y minus 18 equals 0. Of course, I have to set everything equal to 0 because it's quadratic. Knowing that both terms are negative, I can square as if they are both positive because of this reason. Can anyone give us y plus 3 squared, and how many terms would you give me? Good. Plus 2y squared minus 12y minus 18 equals 0. Teresa and I were going to chase each other around the block
No.
at the,
I was
at the end of
actually
the
right.
class tonight.
I was right.
Just kidding, just kidding. Okay, so then we have 3y squared, and then we have minus 6y, and then we have minus 9 equals 0. So y squared with 2y squared, 6y with negative 12y, and 9 minus 18. In the back of my mind is always clean it up, clean it up, clean it up. So can I clean it up?
You can divide by 3.
Of course, thank you, Priscilla. I will definitely divide by 3, make my life easier. So this is y squared minus 2y minus 3, and I'm hoping this. It was a very good pick, actually. Thank you. So y,
Minus 3 and minus 1.
excellent. So y equals 3 and y equals negative 1. So now good, but not good enough. I have to find the corresponding x, and I go back here. Negative 3 minus 3. Perfect. So one solution appears to be this. And now here, negative with negative 1 and then minus 3. Very good. Negative 2 comma negative 1. Do I know that for sure? No, not yet. But I will in a minute. Are we okay so far with this? Before we go back and check. So now I go back to check in the original problem. First I'm going to check negative 6, 3. Negative 6, 3, negative 6, 3, and 3. Negative 6 plus 3 is negative 3, correct. 36, this is 9 times 2. So 36 plus 18, does it equal 36 plus 18? Yes, it does. So I'll say yes. I let you check negative 2 comma negative 1. Is that okay? Very good. Now let's look at an elimination. Please choose one. Same idea, but a little bit more work for nonlinear, right?
28. What you said, between 28, 19, and 20?
Yeah, the next set. Addition method or elimination, yes. Yes?
I'm sorry. So you're plugging in y equals 1 and x equals negative 6.
So I'm plugging in a y equals 3. To check?
Yeah.
Yes. Negative 6, 3. Negative 6, 3. Negative 6, 3, and 3. And then later on, I'll check the second one. So negative 6 plus 3 is negative 3. And then here, negative 6 squared is 36. Plus 9 times 2, which is 18. And here I have 36 plus 18. That's okay.
Yeah, I messed up.
Is this better? Perfect. I'd rather go back and check. Maybe I made an error, so always stop me. Okay, so let's choose an addition method. Same thing.
20.
Which one? 20? 28. Very good. Let's look at 28. Perfect. Same page, 587. And this is x squared minus 2y equals 8. And x squared plus y squared equals 16. Perfect pick. And then we'll look at the word problem to see when this is applicable. Okay, very good. I have one option, which would be to solve for y and then put y in here. But I'll be in trouble somewhat, because then I have x squared squared. So I'm gonna have x to the fourth. No. But there is another option. If we multiply one of these two equations, I cannot eliminate y. I don't have the same variable. The top equation has y, but the bottom equation has y squared. I can't do anything. But I do see the same thing, x squared and x squared.
So multiply by negative 1.
multiply the first one, let's say, or the other one, it doesn't matter, by -1. So negative x squared plus 2y equals -8, and x squared plus y squared equals 16. And this is pretty nice.
So you multiply times -1.
The first one, each and every term, not missing anything. Yes.
So we can eliminate the x squared.
Yes, and these two are gone. And now we have 3, see? Don't rush like I just did, okay? I just said that we cannot combine them, and I just rushed to combine them. Or after I said we can't. So y squared plus 2y equals 8. When we add y squared to 2y, we can combine them, and 16 minus 8 is 8. So this is y squared plus 2y minus 8 equals 0. And of course, I hope for something easy. So it is y minus 2 and y plus 4 indeed. So then y equals -4 and y equals 2. Perfect. But when y equals -4, I have to go back. I'll go back here. First equation. X squared plus 8 equals 8. Oh. So then x squared equals 0. How many solutions? What is the multiplicity here? 2. It will be a term, but we're not graphing. So x equals 0. So the first solution is 0, comma, -4. Now with y equals 2, I go back to the same equation. X squared minus 4 equals 8. So then I have x squared equals 12. I have no choice but take the square root. And then I get x equals 2 the square root of 3 with plus or minus in front. So the square root of 12 equals 4 times 3.
Take the square root.
The square root of 12 because I'm adding 4 to both sides.
Okay.
So then the solutions are 2 the square root of 3 comma 2 and -2 the square root of 3 comma 2. Any questions?
So when you substitute the,
Yes?
you substitute, is it a -4? Well,
Yes.
Either way, when you substitute it.
I have to
into the
substitute
first
-4
equation,
in here.
and you do like the original equation. Not
Yes, 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 to be on the safe side, because what if I made a mistake here? So I always go back to the original one, yes. Any questions? So it happens that we found 3 solutions. 1, 2, 3. Any questions? Okay, let's look at a word problem. Page 588. 56 at the top. A system for tracking ships. Blah, blah, blah.
Oh wait, I'm sorry. I
Yes.
have a question.
Yes.
The 2. Where did we get the 2 for y from again? Oh, okay. Yes. Okay.
And that's what I plugged in back in here.
Okay.
So it's -4. That's why I got x squared minus 4 equals 8.
So that's 1. So it's 3 solutions.
Yes,
Okay.
1, 2, 3.
Okay. Got it.
So let's see what we're interested in. A system for tracking ships. The length and the width of a rectangle whose perimeter is given and the area is given. The area of a rug. A small television has a picture with a diagonal, blah, blah, blah. The sum of two numbers is 20 and their product is 96. Anything? What would you like to work on?
The rug one.
You want the rug? Okay, let's do the rug. I'm always getting a kick out of CU and what my students choose. And it's so frequently the same thing. It's so amazing. Okay, 60. Page 588. The area of the rug, so when we read, we take notes. So the area is 108 square feet. The length of its diagonal is 15 feet. Find the length and the width of the rug. First, we have to establish how many variables are in the problem. If we find 5 variables, we have to write 5 equations. How many variables are in the problem? Let's read the problem one more time. The area of a rug is 108 square feet, and the length of its diagonal is 15 feet. Find the length and the width of the rug. So how many variables do you think we have in this problem? If you say 2, then we will have to come up with 2 equations. What is the obvious equation here?
Or the area.
Very good. xy equals 108. Perfect. So now we need one more equation. I'm just going to give a hint.
That's a 90 degree.
Correct? What does that mean? Because this is a right triangle. And since it's a right triangle, we can use, like in any right triangle, we could use the,
X plus Y.
that will never happen.
Oh, is this the Pythagorean?
Exactly. How do we write it?
X squared plus y squared is equal to 15 squared.
That's it. The Pythagorean theorem, x squared plus y squared. The sum of the legs squared, always the sum of the legs squared equals the longest side, the hypotenuse, squared.
Sum of legs squared.
Sum of the squares of the legs must equal the longest side squared. Very good. So now which of the 2 methods, substitution or elimination? And you have to say elimination, there is no way, because I don't have the same variables. This is xy, I don't have x squared. This is xy, I don't have y squared. So thinking of substitution is a lost cause. Thinking of elimination is a lost cause. So then I have to solve for either x or y. I have to use substitution. And I have no choice, but I will have to use a fraction this time. I don't like it, but I have no other way. So which one would you like to solve for?
Let's solve for x.
If we solve for x, then we have 108 over y. And then we have to go back and replace x in the second equation by 108 over y and square the whole thing plus y squared equals 225. 15 squared. Okay. Now, we are embarking on a journey. I didn't know how long the problem was going to be, but we just did it with the other class. They chose the same problem. Okay, very good. So, first step, please. I need to solve 108 over y everything squared plus y squared equals 225. First step.
Square of the 108.
Very good. So what do I get when I square? Well, I have an idea. So 108, 11664. Okay, very good. Good. As you've already noticed, I moved 225 to the other side. What type of equation is this now?
Quadratic.
Say it again.
Quadratic.
It has a variable in the denominator.
So it's rational.
It is rational. Very good. Awesome. And next step. And we know what's next. The least common denominator is y squared because there is no other denominator. It's just y squared alone. So then what do we need? For the first one.
664.
That's why I was saying please redo your tests every weekend. Every weekend. We forget. We tend to forget.
You know, multiply minus.
I learned something a month ago and I was looking back and I couldn't remember it. What do I have here? It's the same denominator. So what can I have?
Y squared.
1. It's the same denominator. From y squared to y squared. We're not multiplying by anything. What about here? But the denominator is 1. It was 1 and now it's y squared. So what do I need? Indeed. This is over 1. What do I need? You forgot how to solve rational equations. 11664 plus y to the 4th minus 225y squared. We're adding fractions, right? And they don't have the same denominator. Right?
So because the 11,664, because the denominator was y squared, it was kept the same.
Right. So if I have 1/2 minus 4 plus 3, right? So this is all over 2. Do I multiply this by anything if it's 2 and 2? No. I only multiply this by 2 and this by 2
Okay.
because it's over 1. So that's how I get 1 minus 8 plus 6. Same idea. Is that clear now? Okay, perfect. Good. So now I'll write it over 1. What do I need to do next? Right.
No, not yet.
Yes, you're right. Yes, because it's already, there is nothing I can combine. I'm going to write it in descending order. Y to the 4th minus 225y squared plus 11,664 equals 0 indeed. Okay, what type of equation is this? Now this is no longer rational. It doesn't have a denominator in it. It's quadratic in form and also polynomial. Very good. How many solutions? For sure. How many? 4 indeed. So it's a polynomial equation, but also quadratic in form. Excellent. It's coming back. That's great. So then you will say let W be excellent. If this is W, if this is not, then it was not going to work. The method is not going to work. So if I denote this by W, what is this? Yes, but only if it is true W squared. It is, because when you square y squared, you get y to the 4th. We cannot just fabricate it, right? It's there. We know that. So now the new equation is W squared minus 225W plus 11,664. Don't try to factor. The numbers are too big. There's no need for that. We have a method that allows us to solve it quickly. What is it? Thank you. Negative 225, the opposite of negative 225, the square root of 225 squared minus 4 times 11,664 divided by 2 times a. You're making my life very easy. Here's why. Because, as I said a minute ago, I had the class pick the same problem, and I did not believe it. So 225 minus the square root of 225 squared minus 4 times blah, blah, blah. And with plus in front and with minus, I'll wait for you to come up with the